Hi guys, welcome back to the channel. So let us start with today's topic. The topic is recursion. So let us know what is recursion for actually. The function which calls itself to solve complex problems elegantly is called a recursion, which is a mind-blending logic. So let us go deep into the recursion. So as I already mentioned, when a function calls itself a part of its own definition to solve a smaller version of the same problem until the base case is reached is called recursion. So let us know what is the base case actually is. The base case is a condition where the recursion stops and no more recursive calls will be allowed. So what is no then recursive case is? The function calling itself with a smaller input is called recursive case. And let us know what is frames of stack. So each call is added to call stack in memory. So like that, when each recursive call gives some input, that input will be added to stack memory and it will be stored for the final recursion purpose. And let us know the analogy of recursion. Standing between two mirrors, each reflection contains another reflection and getting smaller until it disappears is called a recursion example, and it will be a real life analogy also. And let us go with the clear anatomy of recursive function. So here we can see the function factorial, which is the best example and easiest example for recursion. So the base case is if n equals to 0, return 1. It means that if the value reaches to 0, it should return 0. It should not return 0 and it should return 1 and stop the recursive calls and finally return the value of factorial. So when the function enters the process, so it will first check the base case. If the base case is not executed, then it checks the other values. Here is the recursive case example. Here we are calling the function in the function itself is called recursive call. So every recursive function must have a base case and a progress towards it and the factorial call stack. So here you can see that the same factorial problem with example. So here is the base case if it reaches 0, then the starting value for factorial 1. For factorial 2 it is factorial of 2 n into factorial of n minus 1, 2 into factorial of 1. So like this it grows downwards as cells are added. Each cells wait for the next one to return before it can compute its own result, and the stack call unwinds from the bottom upward. Like this, it goes from factorial 0 and uses the value of factorial 0 in factorial 1 and uses the factorial value 1 in factorial 2 and uses the value of factorial 2 in factorial 3 conversion. The same in factorial 4 also goes there. Like the unwinding goes upwards and returning values back up. So let us go with the second example, Fibonacci series. So Fibonacci series is the series generating the concurrent values by adding the previous number and the present number and generating a new number. So here you can see here the base case is if n less than or equals to 1, return n. So for an example, let us generate Fibonacci series for 6. Fibonacci number for 6. The Fibonacci term of the sixth term in the Fibonacci series. So let us go into the function. Here we have two base cases. If n less than or equals to 1, which has n equals to 0 and n equals to 1. If n equals to 0 means it returns Fibonacci of 0 equals to 0 and Fibonacci of 1 equals to 1. And here we have two recursive calls, which is a multi-recursive call function, which is the best example for solving the complex problems and branching into two subproblems. And it is inefficient without memoization. So memoization is the same values recalculated with multiple recursive call functions. So here you can see that it will go with fib of n minus 1, which is, let us take the example of fib of 5, 5 minus 1, sorry, 6 minus 1, which is 5, and 6 minus 2, which is 4. It will check the recursive call function twice and return the value according to the given input and returns the value as 8 because the sixth term of Fibonacci series is 8. So let us know the basic difference between recursive function and iteration. Recursive function is calling the same function which is defined again and again to break its complexity and to make it easier for execution. And when it comes to the iterative function, here you can see that iterative function means iterating the variable n number of times until we reach the goal and we find the solution. So basic aspect, we use call stack memory in recursion and we use loop variable memory in iteration, and it is for cleaner. The readability is very clean for tree problems in recursive function, and when it comes to iteration, it is very simple for clear and simple loops. The speed is, when compared to iteration, it is very slower, and function overhead is advanced than recursion, whereas in iteration it is generally faster. The stack overflow is possible in recursion, whereas it is not. It is not a problem in iteration, where the iteration holds a problem which is infinite loop possible. The types of recursion, which is direct recursion, indirect recursion, means calling the one function in another function in this function, and the other one is tail recursion, and the other one is tree recursion. So let us know one by one them each. Direct recursion, a function which calls itself directly, and the indirect function in which the function A calls B and B calls A. Tail recursion, recursive call is the last operation which can be optimized. And the one more thing is tree recursion, multiple recursive calls in one function. As I already mentioned, Fibonacci is the best example of a tree recursion. So real world use cases, we have many real world use cases which include directory traversal, tree structures, search algorithms, backtracking, sorting algorithms, and mathematical problems. So let us go with one by one actually. When we are navigating the folders and subfolders recursively, it is very useful. And we are working with binary trees and binary search trees and DOM traversal, which is very useful. And in search algorithms like binary search and depth first search, it is very helpful. And it is also useful in maze solving, Sudoku, and Enquin's puzzle. And sorting algorithms like merge sort, quick sort use recursion heavily, and some mathematical problems which are frequently observed in coding platform questions like towers of Hanai, GCD, and power functions. So these are the common pitfalls and best practices. So common pitfalls are missing the base case, which leads to infinite recursion and recursion error. And the second one is wrong base case. Wrong stopping condition will give wrong results. And stack overflow, which is the recursion limit of stack overflow is basically 1000. And the last one is no progress. When the recursive call does not reduce the problem size, if it has no progress, then the recursion has no value itself. And let us go with the best practices. Always define the base case first, which then which is defined before the recursive step actually, and use system dot set recursion limit, which is a function to increase the limit when needed, and use memoization, which catch the results with at the rate LRU underscore catchy or a dictionary, which is very helpful in maintaining the values accurately. And the last one is prefer iteration for simple loops. Use recursion only when it is truly clear, truly cleaner and clear. So recursion error is a maximum recursion depth exceeded. So when the system reach to maximum limit, it will show the error. And let us go with a quick recap of today's session and what we have covered today. Today we have covered what is recursion and how it works, and the base case and recursive case, factorial and Fibonacci examples, how the call stack works, and recursion versus iteration trade-offs, types of recursions, real-world problems, and common pitfalls and best practices. Tomorrow's topic is sorting algorithms, which is a part of memoization and dynamic programming. And we have also discussed common pitfalls and best practices. And I'm gonna say some problems. Please work on it and comment down the solutions. So write your own code for factorial, Fibonacci, sum of n numbers, and reverse the string using recursion. And the main outcome of today's session is when students can understand recursive logic deeply, they can build efficient codes and they can solve any kind of problems easily without facing any errors. So please like, share, and subscribe and practice recursion today. Thank you for watching.